Hello student, today we learn rules to obtain integrating factor of differential equation m dx plus n dy is equals to 0. Now, in the previous lecture we have learned the rule number 1. Now today we're gonna learn the rule number 2. And what is the rule number 2? If dou n by dou x minus dou m by dou y upon m is a function of y only, say gy, then the integrating factor, then the integrating factor, integrating factor is equals to e raised to integration gy dy, right? So what rule number 2 says that if dou n by dou x minus dou m by dou y upon m is a function of y only, say gy, then integrating factor is equals to e raised to integration gy dy. Okay. Now let us see example on the rule number 2. Okay. Now, so first of all, step number 1, if you saw this type of question, then step number 1 is always compare with m dx plus n dy is equals to 0, right? So this is equals to, what is m here? M is this 2xy square minus y, and what is n here? X. So let us calculate dou m by dou y, and what is dou m by dou y? It is 4xy minus 1, and what is dou n by dou x? It is 1 only. So here clearly dou m by dou y is not equals to dou n by dou x. This implies given differential equation is not exact. Given differential equation is not exact. We call it as a 1. Correct? Given differential is not exact. Now, so equation number is not exact, but we can convert it into the exact one by multiplying some factor, and that factor is called the integrating factors. Okay. Now, the rule number 2 says that if dou n by dou x minus dou m by dou y upon m is equals to g of y, which is function of y only, then the integrating factor is e raised to integration gy dy. Let us calculate this quantity. Dou n by dou x minus dou m by dou y upon m. Okay. Dou n by dou x minus dou m by dou y upon m. Right. What is dou n by dou x? It is 1 only. 1 minus, what is dou m by dou y? 4x minus 1. 4x y minus 1 upon, what is m here? 2xy square minus y. 2xy square 2xy square minus y, right? Okay, so we can write it as 1 minus 4xy minus minus plus, so it is plus 1 divided by, we can take y as a common, so y 2xy minus 1. So we can write it as this 1 plus 1 is 2, so 2 minus 4xy upon y 2xy minus 1. We can take the 2 outside here or minus 2 outside. So minus 2 if we take common, so it is minus 1 plus 2xy upon y We can write this term as minus y plus 2xy. This term and this term will get cancelled, and we are remaining with minus 2 by y, right? Minus 2 by y. So it is function of y only. It is function of y only. So we can write integrating factor as e raised to integration of function of y dy. Right? E raised to, what is gy? It is minus 2 y, minus 2 by y dy. So e raised to minus 2 integration 1 upon y dy. So we can write it as e raised to minus 2 log y. Right? So this minus 2 we can take to the power, because this is base e, log e y raised to minus 2. Since we have a formula, right? B log a is same as log a raised to b. Correct? Okay. Now this e and this e, that means log and this e get cancelled. So it is y raised to minus 2. So this implies integrating factor is equals to 1 upon y square. Right? Multiply integrating factor is equals to 1 upon y square to equation number 1. So what is the equation number 1? 2xy square, 2xy square minus y dx, minus y dx plus x dy, x dy is equals to 0. So if we multiply by integrating factor 1 upon y square to both sides, so this is 1 upon y square into 0. Okay. So this is equals to, now this y square get cancelled. So it is 2x minus y upon y square, 1 upon y dx plus x upon y square dy is equals to 0. Okay. So we have converted the equation number 1 into equation number 2, in which equation number 2 is exact differential equation. There is no need to check that equation number 2 is exact or not. Right? Okay. Now, so equation number 2 is exact differential equation with m dash is equals to, m dash means dx का coefficient, because dx का coefficient generally it is m, but we have already m used in the previous one. So m dash is 2x minus 1 upon y, and n dash is equals to x upon y square, x upon y square. And we know that solution to exact differential equation is integration m dash dx, keeping y constant, or treating y as a constant variable, plus integration terms free from x in n dy is equals to c. So integration, what is m dash here? 2x minus 1 upon y dx plus integration terms free from x in n. What n dash? Sorry, it is n dash. What is n dash here? X upon y square, right? So we have to take the terms free from x now. So n dash contains only one term which is contain x variable. So there is no terms free from x in n dash. So we have to write it as a 0, right? 0 dy is equals to c. Y treated as a constant. Okay. So 2x का different integration with respect to x is 2x square by 2 minus 1 upon y constant. 1 का integration is x plus 0 is equals to c. So this is equals to x square minus x by y is equals to c, or we can write it as x square y minus x is equals to cy is solution to exact differential equation 2, right? So this is the solution to exact differential equation number 2, which is this, and we can write it as, so this implies this is also solution to equation 1 also, right? So for the equation number 1, this is also solution, right? So there is no need to find the separate one, the solution to the equation number 1, right? Okay. So we have learned that rule number 2, and using the rule number 2, we have done the one example, right? Let us see the second example. Second example. Solve y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy is equals to 0. Step number 1, always first of all compare with m dx plus n dy is equals to 0, right? What is m here? M is y raised to 4 plus 2y, and what is n here? N is xy cube plus 2y raised to 4 minus 4x, right? We need the dou m by dou y. What is dou m by dou y? It is 4y cube plus 2, and dou n by dou x is y cube with respect to x, 2y raised to 4 is 0, and this is only minus 4, right? With respect to x, na, so it is xy cube ka derivative with respect to x, y cube only. 2y raised to 4, it is free from x, it is 0, and minus 4x means it is 4 only. So this implies dou m by dou y is not equals to dou m by dou x. So we call it as a 1. So this implies equation 1 is not exact. Equation number 1 is not exact. But we can convert it into the exact differential equation by multiplying some factor, and that factor is called the integrating factor. And we have learned that how to find the integrating factor by the rule number 1 and rule number 2. Now, here first of all you calculate dou n by dou x minus dou m by dou y upon m. So what is dou n by dou x? It is y cube minus 4 minus dou m by dou y. It is 4 y cube plus 2 4y cube plus 2 divided by, what is m here? Y raised to 4 plus 2y. So we can write it as y is equals to minus 3y cube minus 4 minus 2, that means it is minus 6 upon y raised to 4 plus 2y. Here we can take minus 3 common, so it is y cube plus 2, and here we take the y as a common, so y cube plus 2. We can cancel it out, this common factor. So we are remaining with minus 3 by y, which is function of y only. So this implies integrating factor is equals to e raised to integration gy dy, right? So this is equals to integration, what is gy here? Minus 3 by y dy. So we can write it as e raised to minus 3 integration 1 upon y dy. So this is e raised to minus 3 log of y to the base e, and we can write it as this e raised to log e y raised to minus 3. Now since we have b log a is equals to log a raised to b. So we can write it as this e and e log e, and this e get cancelled. So this is y raised to minus 3. So this implies integrating factor is equals to 1 upon y cube. Correct? Y raised to minus 3 is 1 upon y cube. So multiply integrating factor is equals to 1 upon y cube to equation number 1. Now, what is the equation number 1? 1 upon y cube into equation number 1 is y raised to 4 plus 2y dx, y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 x y cube plus 2y raised to 4 2y raised to 4 minus 4x dy is equals to 1 upon y cube into 0. If you multiply y cube to the both the terms, so it is y raised to 4 upon y cube, it is y plus 2y upon y cube, it is 2 by y square dx plus this y cube and y cube get cancelled, so this is x plus 2y raised to 4 upon y cube is 2y minus 4x upon y cube dy is equals to 0. We called it as a equation number. So this implies equation 2 is exact differential equation with, what is m dash here? Y plus 2 upon y square, and n dash is x plus 2y minus 4x upon y cube. Right? So equation number 2 is directly, we can conclude it is exact. There is no need to check the equation number 2 is exact. Okay. Now, and we know that solution to exact differential equation is integration m dash dx y as a constant, y as a constant, plus terms free from x in n dash dy is equals to c. Correct? So, integration y constant. So, what is m dash here? Y plus 2 by y square dx plus terms free from x in n. So first term contains x, so we cannot consider this, and third term contains x, we cannot consider. Just 2y not contain the x ka term, so we can consider it. 2y dy is equals to some constant c. So as y plus 2 by y square, the whole term will get constant because we are keeping y as a constant. So the integration of this y plus 2 by y square into x plus 2 y square by 2 is equals to c. So we can write it as y plus 2 by y square x plus y square is equals to c is the solution is the solution to equation 2, and hence this is also solution to equation number 1, right? So we have solved the second example also on the rule number 2. I hope you understood. Thank you.